Welcome to 7.1, Solving Systems of Equations. In 7.2, we're going to specialize in solving linear equations, and that's when we're going to use, and this is review. By the time you're in pre-calculus, honors pre-calculus, this is review. But in 7.2, we're going to use elimination and some techniques specialized just for linear equations, such as number 24. But in here, if it asks us to use method of substitution, we're going to go ahead and do it. Doesn't mean that we're not going to do some algebraic things beforehand. So worth noting is you can take a look at these. I may not do everything here, but we're going to do some of those. We're also going to talk about just solving using your graphing calculator, which should also be review for you. So should be a pretty quick set. We got a story problem or two in here that we're going to take a look at and a couple special cases. But let's go ahead and get started. Solve the system by substitution. We'll do the graphing portion on later problems. First thing, if you're not a decimal fan, we have equations here that we can manipulate. For instance, I could multiply this equation by 10 and get negative 5x plus 40y equals 78 if you don't like the decimals. Or I could be clever, maybe multiply by, well, 5 would clean up that 8, but probably would go with a 10 here. I could multiply the second equation by 10. I could also multiply it by 5. I'm going to multiply the first equation by 10, and I'm going to get negative 5x plus 40y equals 78. Bigger numbers, but if you're not a decimal fan, that's an option for you. The second equation I could also multiply by 10, but I notice I can also get away with multiplying by 5. 5 will clean up that 6 and that 6, so times 5. I get 1x, I get minus 8y's, and let's see, this would be equals negative. It would be 15 and 3, 18. So I'm just trying to point out you don't have to work with the decimals there. And if we were doing this problem by elimination, we'd probably multiply row 2 by 5 and add these together. But we're going to use substitution. So substitution, we can do it from here. We can do it from here. You want to look for an easy variable to solve for. And in this case, the easiest variable is this one right here. It becomes x equals, add 8y, 8y minus, joins a minus 18. And then I want to take this and substitute it into there. And I get negative 5 times 8y minus 18 plus 40y equals 78. Just substitution. I'm just substituting 8y minus 18 in for x in the other equation. Okay, so now I've got negative 40y plus 90 plus 40y equals 78. And sure enough, special occasion right off the bat. 90 equals 78 when those cancel, and at this point two things could happen. If the variables cancel, we can either get a true statement or a not true statement. If it's a true statement, then we're gonna later on talk about what's referred to as a point generator. We're gonna choose some points on the line, but in this case 90 doesn't equal 78, so this can't be true, this can't be true. We can't have a solution for these. These are actually parallel lines if we were to graph these, and you can graph them and check that. So this is no solution. Okay, likewise, don't like fractions. What can we multiply this first equation by? 4. That would give me 2x plus 3y equals 40. Second equation, I can multiply it by 4. I get 3x minus 4y equals 16. If we're doing this by substitution, there's no real easy variable to solve for. I could solve for this x and divide 2, but I'm going to get a fraction. If I divide 3, I'm going to get a fraction. Divide 3, fraction. Divide 4, fraction. I'm going to take this one, I'm going to solve for x. So I'm going to get, let's see, x equals, it would be 40 minus 3y, and then I have to divide both sides by 2. So divide 2, and we get x equals 15 minus 3 halves y. So I'm going to take that value and substitute it for x here. So I get 3 times 15 minus 3 halves y minus the 4y that was already there. Again, I want to back up just for a moment here. I would rather do this without substitution. I'd rather, multiply this row by 3 or this by 3 and this by -2 and do the elimination. But for right now, we're going to do substitution. So minus 4y equals 16. I get 45 minus 9 halves y minus 4y equals 16. Hey, I don't like fractions. Let's get rid of them. Going to multiply both sides by 2. I get 90 minus 9y minus 8y equals 32. Let's see, that's negative 17y equals 32 minus 90, or y equals negative 58 on negative 17. Y is 58/17. Not the prettiest answer. Sorry, didn't track down. Not the prettiest answer, but that's what y is. So now I can take that 58/17 and put it right there to figure out what x is. X is 15 minus 3 halves times 58 on 17. And at this point, I'm just going to get lazy with this, as you may. And I get 15 minus 3 on 2 times 58 on 17. Enter. And math and fraction, 168 on 17. So my ordered pair solution is 168/17, 58/17. So kind of probably problems in the past when you did this ended with nice convenient integer answers, and you'll have some of those, but I didn't really want to specialize in things that you've been doing maybe since 7th grade for some of you. Okay, as promised, here we've got a word problem, and it's an interest problem. You're given a yearly interest earned from a total of $18,000 invested in 2 funds paying the given rates of simple interest. Simple interest. Interest equals principal times rate times time. Not as complicated as some of the interest formulas we've worked with prior to this. And this is a yearly interest, which implies time is 1. So if t equals 1, we're just dealing with principal times rate equals interest. So I'm going to set up a chart. Principal times rate equals interest. And we've got 2 different funds. I'm going to call this, or 2 different rates. I'll just call it Fund 1 and Fund 2. Fund 1 has a rate of 0.06. Fund 2 has a rate of 0.03. I don't know how much I put in here. I don't know how much I put in there. I'm going to let this be A went in here and B went in there. But I do know that A and B add up to 18,000. So this would be this times this, 0.06A. That's how much interest in the first fund. 0.03B. That's how much interest in the second fund we have. And what do we end up with? Write and solve a system of equations to find the amount of interest, invested in each. So I've got, how much total principal do we have? A plus B. How much total interest did we get? 0.06A plus 0.03B. What do I know about this? I know that A plus B equals 18,000. And write and solve a system of equations to find the amount invested in each. We earned an interest, a total interest of 840. So 0.06A plus 0.03B equals 840. I don't want to view updates. Sorry, I just had a glitch on my computer. So we have these two equations. It says write and solve each system. Now we could solve this system very easily. I could multiply this row this by 100 and we'd clean out the decimals. I'm going to go ahead and well, let's do this. I'm going to solve this for A. A equals 18,000 minus B. And I'm going to solve this one for A. A equals 840 minus 0.03b, all divided by 0.06. And now, because I'm going to give you, on any word problem, I'm going to allow you to use calculator. So here's where I said we'd use calculator on some later problems. So y equals, we're going to clear that out. I'm going to treat this like y equals, and my b value is going to be like my x. So it's going to be 18,000 minus x. And then I've got another equation, 840. Whoops, need parentheses here. Parentheses 840 minus 0.03x. And I'm going to divide that by 0.06. And I don't know where those things are going to intersect, but that's what I'm interested in. But I understand this thing's all the way up to 18,000. I'm going to go window 0 to, see, A and B are the amounts I invested. So I'm going to go to 18,000. And then I'm going to zoom fit this graph, because the biggest amount that I can invest in either one of those is 18,000. So I'm going to go zoom fit. That's zoom. What is zoom fit? I know zoom fit. Zoom fit, zoom 0. And there's the first graph, and there's the second graph. And if I go second calc intersect and get close to it, hit enter, that's the first curve, enter, that's the second curve, enter, and it says x is 8,000. Don't forget, our x is our b, and y is 1,000, or is 10,000, excuse me. So y is a is 10,000, and b was my x is, or b is 8,000. And of course, we could do that, we could solve this by hand if need be. All right, now, not linear. Solve the system by method of substitution. Use the graphing calculator to verify your results. So I want to find an easy variable to solve for. And I would say this y is easy to solve for. I don't really want to solve for that x. This x is easy to solve for. This y is easy to solve for. If I solve for this x right here, I'm going to get 4 minus y, and I'm going to put 4 minus y in there for x, and I have to FOIL. So I think I'm going to solve for this y right here. So I get y equals 4 minus x, and I'm going to put 4 minus x in place of y. 2x squared plus 4 minus x equals 3, which is quadratic. 2x squared, I'm going to have a minus x. I got a plus 4 and a minus 3 plus 1 equals 0. Factors of positive 2 that add up to negative 1. And at first we might think like, well, negative 2 and 1. But this is factors of positive 2 that add up to be negative 1. There aren't. So if only there was some kind of formula for solving quadratics. X equals opposite of b, 1, plus or minus square root b squared, 1, minus 4 times a times c, all on 2a, 2 times a, 4, or I get 1 plus or minus square root of negative 7 on 4. We have no real solution. We'd have imaginaries if we were in imagination land. This is 1 plus or minus I root 7, I squared is 7 on 4. But we're working in reals. Okay, so there's substitution for you. Just have to solve for an easy variable. Use a graphing calculator to approximate the points of intersection. So as easy as this, y equals clear. We'll solve these guys for y. I get y equals x if I add y. Here, if I add 2y, I'm going to get and subtract 6, I get 5x minus 6 equals 2y, or y equals divide 2, 5 halves x minus 3. So we just graph those guys. So I've got y equals x and y equals, I'll jump up here, 5 divided by 2 times x minus 3, and I'm going to go to zoom standard here, zoom 6. So I think it's going to happen fairly close to 0. And it did. Second calc, intersection. Get close to it. Ask for the first curve, that's the first one. Oops, I didn't hit enter. Ask for the first curve, that's the first curve. Ask for the second curve, hit enter, and we end up 2, 2. So the ordered pair is 2, 2. Oh, that's easy. And I'm going to tell you, number 55 is going to be easy. Let's jump over to that. Solve this thing for y. I get y equals, I would subtract x. It would join a plus 8, and that would all be divided by 2. This one's solved for y. So it's clear. Let's go back to y equals, clear this, clear that. I'm going to go quantity, negative x plus 8 divided by 2. I don't have to put it in slope-intercept form, you may. And then I'm going to go 2 plus ln x. And let's see if that happens in zoom standard as well. So there's the linear equation. There's the logarithmic one. Second calc intersect. Get close to it. First curve, y1. Second curve, y2. Guess. So I get approximately 2.318, 2.841. Excuse me. All right, now this one. This one's sneaky. We may recognize that this is 2 circles. I need to solve this for y. First equation, y squared equals excuse me, y squared equals 25 minus x squared. Careful. This is y equals plus or minus square root of 25 minus x squared. All right, y squared equals 41 minus x minus 8 squared. So y equals plus or minus square root of 41 minus x minus 8 squared. So how are we going to graph that? I'm going to graph this plus as y1, the minus is y2, the plus is y1, and the minus is, or the plus is y3, and the minus is y4. Let's see what I'm talking about here. Y equals, clear it, clear it. So this is going to be positive square root. Nope, not that. Delete clear. Positive square root 25 minus x squared, the top half of that circle. This is going to be negative. And you can actually do this. This is kind of neat. See the vars button? I can go to vars, my y vars function y1. That's just the opposite of y1. It's just negative, which is exactly what we want there. So for y3, I'm going to go positive second square root 41 minus quantity x minus 8 squared. And I'm going to go back into vars, y vars. What function do I want? y3, but I want the opposite of that. Second, insert a negative. You certainly could type the other in, but I just wanted to illustrate that. Let's see if this fits in Zoom standard. Not entirely, I don't think, but let's go ahead and take a look. Let's go graph. Top half of a circle, even though it looks like an ellipse. And there's second circle. And I don't need to see the rest of that second circle because I know where my intersection points of the two curves are. First circle, second circle. So second calc intersect first curve. Got to be careful here. So right now I'm on Y1. Enter. I don't want that one. So I'm just going to bump with my cursors up or down. Let's see. I want that one. I want Y3 because that's in the same spot. And guess we get 3, 4. And then we got another one underneath there, which I suspect might be 3, -4, but let's go second calc. Did I not get that? Yeah. Second calc intersection. Now I don't want Y1. I'm going to jump onto Y2. Ooh, that's good. Enter. I don't want Y3. I'm going to cursor up, down. You can see that I'm cursoring up, down to jump between those. Y4. Enter. Enter. And that is 3, -4. And finally, I didn't leave much room here. I think that this was meant to bump onto the next page, but something happened in the formatting. Use graphing calculator to graph the cost and so we have a cost function, we have a revenue function. I guess it's based on our sales X. And a very, very common thing to look for in a business is, hey, we're going to lay out some money here. When are we going to be at the break-even point? So that's just when does cost equal revenue? Oh, so for graphing calculator on this, if we get to use a graphing calculator, couldn't be any easier than that. Let's go into Y equals, clear out what we have here. And my cost function is 7.8 square root of X. Step out of there, plus 18.5. And my revenue is 12.84 X. And just for the sake of it, I'm going to go ahead and not think like sometimes people do, and I'm just going to graph this. And we got some issues here. So then I'm going to realize, holy smokes, the cost is 18,000 and up, and the revenue is 12.84 times each unit. This thing's got to go all the way up to 18,000. But let's go ahead and just zoom fit this graph. Zoom 0, as we did earlier. So there's my revenue, starts all the way up there. My cost, we got to go a long way to get up to there. Or my cost is up here, revenue's down there. So I guess I'll go window, I don't know. We got to make $18,000 at 12. I'm going to go out to 1,000 without thinking much about it. I'm going to go zoom fit. Zoom 0. I don't think that's going to be far enough, but maybe we'll see some progress being made. Okay, looks like by 2,000 we'd make it. Window, 2,000, and zoom fit 0. So there's our cost, and our revenue increases, and there's what we're looking for. So second, calculate intersection, get near it, hit enter for first curve, enter for second curve, enter for our guess, and it says that X, and really X is all we're looking for. This is the amount this will be our cost and our revenue when our sales are $1,464.05, or our sales, what is it? It's the number of sales. Find the sales, not the value of the sales. Find the sales. Basically we need 1,464 sales. Now, find the sales X necessary to break even. So that would be our best answer. That's virtually breaking even at that point. If it said to be profitable, well, we're profitable once we make that next sale, 1,465 sales. Okay. Some quick, some going to take a while, but really not too bad. That's a 25-minute video. This is a flipped classroom this year, maybe not every year, but for 2018 flipped classroom, you'll be working on this in class with classmates tomorrow. You will have a substitute in there. He'll be able to help you.